Okay, guys, it is lesson 8, and we are still talking exponents, kind of like I told you last week when I was like, yeah, this stuff's going to be kind of important. Let me kind of explain why. This week is not just rules of exponents, but how do you go between the worlds of exponents and radicals, and like, why is that even important? Why do I care? Is kind of what I put. Well, here's a good reason why. Everybody knows the answer to this, right? 8 squared. Well, everybody, even my 10-year-old, knows how to work that math, and that's just 64. But if I asked her, or even you, okay, what's 8 to the 2/3 power? That's a little harder to wrap your brain around, right? So it becomes this like, what? Like, how do I even kind of comprehend that? Do I have to cut this into thirds somehow? I mean, like, what's happening? So that's why this is going to be important. So let me show you the rule, and then this example will be possible. So exponents to radicals. So if I have something to the, I'm going to call it a over b power. So my base is x, and I'm raised to the power of a over b. Then all that means is that this number that's in the denominator becomes the index of the radical. So it's going to be the bth root. I know that sounds weird. The bth root. It's this root of x, and then that is raised to the a power. Now, I can either put the a under here, or I can put the a out here. I usually prefer to put the a out there because a lot of times that makes it possible for you to be able to do the math. Let me show you. Let's bring this back down, this 8 to the 2/3, okay? If I want to work that out, what that means is the 8 is the base and it goes under a radical, and the denominator is the root, and this squared I'm going to slide out here, okay? And this now becomes math that's possible to do because we know the cubed root of 8, right? That's just 2. 2 times 2 times 2 is 8. So this is a 2, and then it's 2 squared, which is 4. So that becomes pretty easy. So let's go the other way with it. If we have a radical, and it's like, I don't know, let's see. Maybe it's like, I'm going to try to do one. Well, okay, never mind. We're doing the rule first. Okay, so if it's the C, I'll put a C here. I'll put an X here. I'll put a P here. All right, so if you have something like this, the cth root of x to the p power, we're just going to do the exact opposite of this, okay? So when we come out of this form, it just means the base stays the base. Whatever power is on it here or on the outside, okay, those are the numerator. And then whatever is the index becomes the denominator. So it's x to the p over c power. Now, I don't use this a lot. The only time I use this is if I am combining many terms. Combining, and I'll put multiple x terms. And I'll show you an example of what I'm talking about. If somebody asked me to do x times the cubed root of x, and then I was like, what? Like, how do I even work that out? Okay, if I saw that and I had to simplify, that x is still an x, it's just to the first power, right? But in the parentheses, I would rewrite that to make it a possible problem to put them together. The x is underneath the radical, so it's the base. Now, I need a numerator and a denominator. Well, the numerator is whatever power this is being raised to. When no power is visible, it's just a 1, right? There's an invisible 1 there. So that would be my numerator. The 3 is the index. It would be my denominator. And hopefully you see it, but the power of this now kicks back to last week, guys. What did we do last week? If you have the same base and they're being multiplied, what do you do with their exponents? You add their exponents. So this becomes x to the 1 1/3 or 4/3, And you can either leave your answer like that, or sometimes they'll want you to go back and write it as a radical. So using this rule back here, I can go back and turn it into some kind of radical, and it makes this be able to be combined. Okay? So that's just one use for that. So let's put it into play with multiple terms, okay? How to simplify a radical. And just so you know, this is an important page for, of course, what we're doing right now in Algebra 2. This will show up sometimes on an SAT or ACT. This also is a huge chapter in a college algebra course. So if you decide to take a college algebra course early, like at TCC or something, I just tutored someone in that, and this made up a good section of their year. Okay, so this is important stuff. So how do you simplify the radical? And I'm just going to say one term at a time. One term at a time. Just kind of view everything under the radical as its own separate creature and try to reduce it like that. Okay, so the way that we could do that is, first let's examine this whole square root of 125. Okay, now there is not a square root of 125, but you probably remember how to break that down. The idea is to find two numbers that make up 125, but you want one of those numbers to have a square root. So I'm thinking that's 25 times 5, right? And once you break that part down, then the square root of 25 is 5. And then underneath the radical, you are going to be left with that 5 that's right there. Okay, so I just took the 125 and worked it down to the bottom. Now I'm going to focus on the square root of a to the third. Okay, so on this one, I'm going to show you what's really happening, and then I'm going to show you a shortcut when we get to the next one. Okay, so if we take the fact that a cubed is underneath the square root symbol, well, what's the invisible number that's right there? It's not a 1, right? This is the square root of something. So there's an invisible 2 out there. And using our rule from above, we can write this as a to the 3/2 power. Okay, so remember that that stays a numerator and the index is the denominator. Now, what does this mean, a to the 3/2? Well, we know that that's just 1.5, right? Isn't 3/2 the same as 1.5? Well, if 3/2 is the same as 1.5, then that's saying that I have a is raised to 1 whole power, okay? And then there's a half left over. So I can almost work backwards from what I did in this box right here, and I can think of this number as a times a to the 1/2. Because there's 1 whole a right here, and that was the extra half that was left over. And what this means is that this a has now escaped the square root symbol, and this one with the 1/2 that's still left over, we could go back and rewrite it as a radical. The numerator is a 1, so this is a to the first right here, and then the denominator is a 2, so that's a square root. You can write the 2 or you don't have to, but so the blue just turned into a square root of a. So that's what the square root of a cubed just turned into, a square roots of a. And then b is the last one left. Now this is b is underneath the square root. I'm going to come right here and do this. So the b is under a square root. And same thing as before. If I have a 1 here and a 2 here, then this is the same thing as b to the 1/2. Now, how many wholes can come out of that, you know? The answer is none. Like, there is no way to turn this into a mixed number. There is no way to have a whole one and then some leftovers. And so because of that, you cannot reduce this. You cannot reduce it, which means that this is as simplified as it gets. So what it was is what it was, and we can't turn it into anything else. And then you just put all 3 pieces together. Like I said, long true explanation on this one, and then we'll go to shortcuts, guys, so just hang with me. I know this is taking a while. These 3 pieces get put together. Everything on the outside of the radical, you just copy together on the outside of the radical. Everything under the radical goes under the radical. So a 5 from that, an a from that, and a b from that. this is your final answer. Now I wanted to show you piece by piece by piece to prove to you that the junk up here is legit and that is actually what's happening in the background. But now, hopefully, if you've seen that and that makes sense, we're going to kind of skip the going and doing all that. And instead, what we're going to do is just kind of try to shortcut it in our head a little bit, okay? So here's what I do. Now, there's no shortcutting numbers ever. There's only shortcutting exponents. So if I'm trying to break down the cubed root of 128, I really am going to have to think about that. And you may have to write down some of your cubes if you don't have them memorized. But hopefully either 8 or 27 or 64 goes into 128. And I actually think 64 goes into it, right? 64 goes in there twice, so I'm going to break that down to 64 times 2. And now I'm going to do the cubed root of 64 is 4. The cubed root of 2 is the cubed root of 2. Now, I'm leaving a little room because there may be something that goes beside it, kind of like in this one over here. There was some stuff on the outside and some stuff on the inside. So I did my number part first, but I'm leaving a little room here just in case and a little room here just in case. And that's when I go and I look at the B. Now, instead of rewriting and doing all that stuff, here's pretty much what you can do. You can pretty much do the division in your head. Because this will be a fraction of 5 over 3. So the way I do it is, how many times does 3 go into 5? Well, 3 goes into 5 once, so I pull out 1b. You can even put your little invisible 1 there if you want. I pull out 1b, and what's the leftovers? Well, 3 goes into 5 once with a remainder of 2. So back here, there are still 2 trapped under the radical. And that is the shortcut way for all of this jib-jab that I was doing back here. Okay, and that is the final answer, 4b times the cubed root of 2b squared. That's how that would work. All right, fun, isn't it? But it's really not that hard. You just kind of do division and look for remainders and stuff. Okay, so now an example of something like this. Well, if I was asked to simplify this, what I would probably do is distribute the 1/2 to each term. So it would be like 16 to the 1/2 and then x squared to the 1/2. And then I would figure out what all this means. Y'all should know that, right? X squared to the 1/2. The rule is to do what with these exponents? It's to multiply. And whenever you multiply these two, what do you get? I'm getting a 1. So all of this just simplifies to a 1. And then 16 to the 1/2, if you're like, I don't know what 16 to the 1/2 is, then you do the rule from the very beginning of this video and you rewrite it. So this is the same thing as 16 is the base, it's under a square root. The 1 goes here, the 2 is the root that it is. So what's the square root of 16? It is 4. And you recopy that x. So that's how you can do a problem like this. Feel free to distribute it to each of the parts and then try to work through, what it means. So the last one, create a problem that with a, what? Create a problem that with a constant and variable. Oh, that does make sense. Okay. A constant and variable that has a perfect square root but is given as an example as an exponential problem. Okay, so given, that did not want a G right there, but it was probably autocorrect on spelling. I just love it. Okay, so this is kind of tricky. Let's think about this a little bit. It has a constant and a variable, so we need to make up a number and we need to make up a letter, and we want it to have a perfect square root, but it's going to be given as an exponential problem, okay? So that means we got to make up something that has an exponent, all right? But we want it to have a perfect square root. So if we're shooting for square roots here, the way to make a square root is to make sure that whenever you have a fraction here, we want it to be a square root, so there better be a 2 down here. Now, we can have whatever number we want at the top, because remember, the number at the top here is just going to be what power we're raising it to, and that's going to be whatever you want. So if we want to keep it simple, we could just put a 1 there. But you could have put, I wouldn't put a 2 because then it all cancels out, but you could put a 3, a 4, a 5, it doesn't really matter. This is the most important part for square root, okay? And now give me a number that has a perfect square root. Well, I'm thinking 36 just because it popped into my head. And then we need a letter here. Let's go with y. And I can't just leave it as a y because it said that it wanted the variable to have a perfect square root. So if I just left it as a normal y, then I'd be taking the square root of y and nothing can come out of it. But if you think back to how I did the shortcut here, as long as these two numbers go into each other evenly, then we will be able to have a perfect root. So I could put a 2 here, and then a 2 and a 2 would totally cancel. And if you're confused, just remember that 2 will eventually be on the outside of the square root. Okay, so I'm looking at this as once I turn it into a radical and I have a 2 out here, I need that 2 to cancel with whatever's here. So pretty much anything 2 goes into. 2, 4, 6, 8, any of those is fine. I'm going to go with 8. And if you want to check yourself, I'm just going to do a little check. What that means is we're going to take that 1/2 and rewrite all of this underneath the square root, and it's all to the first power, so that doesn't really matter, right? So the square root of 36 is 6, and the y recopies, and we have 2 goes into 8 4 times with none left over. So this is a perfect square root because everybody came out and there's nothing left over, and that works. So you have to get creative, and there's many, 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 many answers, but that's how that'll work. So good luck to you simplifying on your notes guide or your practice. If you get stuck, of course, watch the solution and I'll get you unstuck, and that may give you an idea as to how to do the next problem. All right, good luck.